What's the link between humans and other animals? Why am I different from Danny here? Do you know, if we could compare my DNA with his, more than 98% of it would be identical, wouldn't it? Yeah. Do you think that means we're related? Are we related? The idea that species can develop and change has been causing arguments for over 200 years. The evolution of the human race has set off the fiercest arguments of all. An English scientist called Charles Darwin started the great debate on the origin of species. But what led him to come up with such a revolutionary idea? I started off at London's Natural History Museum to find out what links me with a chimpanzee.
Well, we've got here two skulls. Here is a modern chimpanzee, and here's a modern human, like you or me. They're similar in terms of their overall structure because we've got here basically the same number of bones in each skull, we've got the same numbers of teeth, but of course looking at them we can see there are also differences. The brain of the chimpanzee is much smaller than the human brain. It's only about a quarter of the size of our brain. And if we look at the teeth, we can see these very large canine teeth which interlock with each other, as you can see there.
Is there any evidence of some common ancestor?
Well, yes. I mean, because of the similarities, we guess they certainly had a common ancestor a long time in the past, and that they split and went their separate ways, and that's when these differences must have developed or accentuated. And we have got fossils now from about 3 million years ago.
3 million? Wow.
And this is a fossil from a site called Sterkfontein in South Africa. We've got the lower jaw of another fossil from South Africa from the same site. And we can see here that certainly at first glance that you'd say, well,
he looks just like that,
like a chimpanzee. And certainly in terms of brain size, that's absolutely right. But when we look at the teeth, we begin to see something a little bit different, because you can see here that in fact the molar teeth are actually diverging from each other in a more human shape. And the front teeth are not as large as they are in the chimpanzee, and the canine teeth are not large and interlocking. So interesting evidence there of something which may seem ape-like but does have some differences, some really human features.
So 3 million years ago, human beings may have evolved from a creature like this. But such fossils are rare, and there are still lots of gaps in the family tree. The idea that humans and apes might have shared a common ancestor is still regarded as pretty dangerous stuff in some parts of the world. But who was this chap Charles Darwin, and how did he get the idea? And is it just a theory, or is it established fact? Charles Darwin was born in 1809 into a well-off Shropshire family. His father was a doctor, a good-natured but very strict parent. His grandfather, Erasmus Darwin, had already written about evolution at a time when nearly everyone else in Britain believed in the literal truth of the Bible. The book of Genesis was regarded as an exact account of the early history of the world. One scholar had even calculated that God had created the human race in the year 4004 BC on Sunday, October the 23rd at 9 o'clock in the morning. Actually, what mattered to most people was not the exact time and date, but the fact that the human race had been created by God. A few years before Darwin was born, a churchman called William Paley had published a very influential book about the origins of life. And he made the point very strongly that the very complexity of the world we live in argued for a divine creator. Let me show you one of his examples. He said, suppose you're walking along and you find a stone. You wouldn't be particularly surprised by that. There are lots of stones lying around. But suppose walking along through the wood, you found this. Now, if you'd never seen a watch before, it would be very hard to imagine that this had appeared there just by chance. It must surely have been created for a specific purpose. But living things were even stronger evidence of a great designer, Paley said. If you looked at something like the human eye, how could you believe that such a delicate, complex and ingenious organ could come about purely by chance. And to Paley, the human eyeball was absolute proof. It was clearly created by design, and the designer could only be God. If you had no other explanation for our presence here on Earth, then Paley's ideas made a lot of sense. But Paley went on to say that because they had been created by God, all living things were by definition perfect and would never need to change. And it was this assertion that living things never need to change that was going to be challenged by the new ideas on evolution. The geologists had got the ball rolling. They were beginning to realise that rock formations like these in Dorset must have taken millions, not just thousands of years to create. But it was what they found in those rocks that interested people even more. The cliffs near Lyme Regis are one of the world's richest sources of fossils from the Jurassic period, 180 million years ago.
That's a piece of ammonite, isn't it?
In Darwin's time, these cliffs had already been the scene of some of the most dramatic fossil discoveries eever made.
Tiny ammonite in there.
The most famous finder of fossils of all time was a girl called Mary Anning, who was born right here in Lyme Regis, the daughter of the village carpenter. When she was 11, she and her brother found what she thought was a crocodile. Actually, it was the best preserved specimen ever found of an ichthyosaur. She went on later to find the world's first plesiosaur and the world's first pterosaur, a flying reptile. She was brilliant. Some people suggested that these creatures had died in the Great Flood described in the Bible. But others wondered why God should have created species which he then allowed to go extinct. It just didn't fit with that traditional idea of a perfect world where nothing needed to change. Mary Anning's ichthyosaur wasn't the only thing that had disappeared. Evidence was mounting that many, many species had suffered change and had become extinct. In fact, it was becoming increasingly obvious that the world was much, much older than people had believed.
So what's in here?
But why did some species die out? And how did others develop and change? Back in the Natural History Museum, Chris Stringer pointed out that scientists had come up with evolutionary theories before Darwin was even born.
Darwin wasn't the first to propose evolution had happened. The idea had been around for a long time. For example, there was a French biologist called Lamarck, and he believed that creatures had changed through time by passing on characteristics that they accentuated during their life. So, for example, if giraffes constantly were stretching their necks to reach vegetation, then that characteristic will be passed on, and the stretched neck would be passed on to the next generation, and that in turn could produce an even more stretched neck.
Today we know that Lamarck was basically wrong. Characteristics we acquire in our lifetimes aren't passed on to our children, so that, for example, trees that are bent in the wind don't produce bent saplings. And skinny parents who take up bodybuilding don't produce muscle-bound children. However, at the time, his ideas provided at least an alternative to the biblical view of creation. In 1830, no one would have guessed that the young Darwin was going to become a great scientist. He was a rather aimless young man who enjoyed hunting and shooting. His father predicted he would be a disgrace to the family. To keep his dad quiet, he thought about becoming a vicar, a cushy job which would have allowed him to pursue his love for natural history. Anyway, before he had time to become a clergyman, an opportunity came up that changed his life forever. A Royal Navy survey ship, HMS Beagle, was about to set off to chart the coast of South America. The captain wanted an educated companion for the long voyage, and Darwin was put forward to join the crew as the ship's naturalist. The voyage lasted 5 years and took Darwin round the whole world. In the Galapagos Islands off Ecuador, he found species which were unique to these tiny islands, and which would play an important part in the development of his ideas. As a young man, he had believed in the biblical story of creation. But as the beagle slowly made its way back to England, Darwin began to reflect on what he had seen.
And this was where a whole lot of Darwin's specimens ended up, along with those of a mass of other enthusiastic collectors who scoured the globe, shooting all sorts of exotic creatures and bringing them back. In fact, museums had to construct whole new buildings to house the hundreds of thousands of specimens. Now, look in here. This straw has got some wonderful birds, collected by another enthusiastic naturalist called Alfred Russel Wallace. Look at this extraordinary bird of paradise. Look at that tail. Wallace had interesting ideas of his own, and his research was to have a profound effect on Darwin later on. Now, over here are some specimens collected actually on Darwin's trip on the Galapagos Islands. And you can see they're not terribly exciting looking. In fact, they're rather boring. And he was not very interested, and he just shot a whole lot and shoved them into one bag and didn't even label them properly. But they turned out to be some of the most valuable pieces of evidence for his growing ideas on evolution.
The birds were all finches. They all looked pretty similar, but they came from different parts of the islands, and there were significant differences between them.
Darwin handed over all his specimens to various experts for examination, and he took the birds to the bird expert, a chap called John Gould. And it was Gould who said that these boring-looking birds were really exciting. And the extraordinary thing was the variation between them. Look at the beaks particularly. You see, some of them are tiny and very pointed, some are much chunkier. In fact, if I take this chap here and put him beside that one, just look at the difference. It's absolutely colossal.
Darwin wondered whether there could be a link between the way the beaks had developed and the habitat the birds lived in.
Imagine that on one of the Galapagos Islands there's loads of grass with insects in it. Then any finches with small beaks are going to be favoured because they'll be good at teasing out those insects. And therefore those finches will have more babies, and their babies will tend to have smaller beaks, until after many, many generations you might get finches like this with absolutely minute beaks. Whereas on another island, where there are no insects but lots of seeds, then finches with bigger beaks will be more successful. And they'll have more babies, and the babies will have bigger beaks, and so on, until you might get finches like this with great big seed-cracking beaks. And Darwin thought maybe that was how separate species actually developed.
It was not just wild species which occupied his attention. He became very interested in the way domestic animals could be crossed to produce new breeds.
The amazing thing about dogs is they come in a huge variety of shapes and sizes, and yet they're all one species. Now, obviously, there's been an enormous amount of variation, and Darwin was very interested in this, so he spoke to all the leading dog breeders to find out how they generated such diversity. But even they couldn't tell him how it happened in the wild. And he was completely stumped by that until he came across an essay by a chap called Thomas Malthus.
Malthus was concerned with humans rather than animals. He believed that the world's population was expanding faster than the food supplies, and that people would have to compete in a fight for survival. This idea of competition between members of the same species had a profound effect on Darwin's own ideas.
Malthus forecast inevitable starvation unless people curbed their reproduction. Now, the fascinating thing is that Darwin was reading Malthus when he got the idea for natural selection, the idea of a rapid increase in population, which inevitably would lead to competition. And it was that was the spark that lit in Darwin's mind.
Competition was the missing link in his theory. The members of a species which stood the best chance of surviving were those born with characteristics which gave them an advantage in life.
Darwin himself put it that if you have overproduction, which naturally every creature does, you get more children produced than can ever possibly survive. That leads to competition. There's genetic variation within a species, as there is in any species. So the individuals that survive and the individuals that reproduce are the ones that are best at surviving and best at reproducing.
Working alone in his study, Darwin had taken more than 20 years developing his theory on the origin of species. Because it went against religious teaching, he knew it was bound to offend many people, and he had held back from putting it into print. But then he learned something which forced him to act.
He got a letter from Alfred Russel Wallace, a young naturalist, in which Wallace laid out the same theory, word for word almost, and Darwin was flabbergasted, staggered. Can't really think why, because you'd think he'd have been worried about being scooped. But anyway, Wallace thought of it, and Darwin was then galvanized into action. But it was Wallace who really stimulated him to get moving and write The Origin of Species.
But Darwin still had one major hurdle ahead. Although scientists were beginning to accept the idea that species had evolved, they found it much harder to believe that the human race could have been created by the same evolutionary forces as animals and plants. Humans were special, they protested. Darwin was convinced this was a load of nonsense. He said people were just animals, particularly they behaved like apes. Now, in 1838, there appeared at London Zoo a young female orangutan called Jenny, a bit like this chap, he's called Beau. And Darwin went to see her and he was absolutely fascinated. He said that when the keeper withheld an apple, Jenny lay on her back and screamed and kicked. And when the keeper gave it to her, she jumped into an armchair and ate it with a huge smile on her face. In fact, he spent quite a lot of time comparing the facial expressions and behaviour of his own children with those of the chimps in the zoo. He was convinced there must be some common ancestry, but he needed proof. At the time, there was no evidence which clearly showed an evolutionary link between humans and apes. Fossils of early human-like creatures only came to light many years later. But when he wrote his next book, The Descent of Man, Darwin was confident that the missing evidence would eventually be discovered.
He realised, of course, that this would be extremely controversial. But the fossil evidence already suggested that other species had changed through time and had evolved. So I think he became confident that the same, man was not going to be an exception. And he actually said in The Descent of Man that in looking for our place of origin, we should look where our closest relatives live. And that's where the gorilla and chimpanzee live. And therefore he actually said in The Descent that Africa was the most probable place of our origins.
So he made a prediction?
He did. He made a specific prediction that most likely it would be Africa that would have the fossil evidence of our evolution when people looked for it. But it was at least another 50 years before any of that evidence began to turn up.
But it did turn up?
It did. It started to turn up, and now we know, of course, that indeed the whole first half of human evolution occurred only in Africa. That's where our original ancestry was.
Darwin's theory outraged the church, and he was satirised in the press. But his theory survived because it fitted the facts better than any other explanation of how species develop and change. But it was going to be another 100 years before people find out how we actually pass on genetic characteristics from one generation to another. And that is the subject of our next programme. That's a good boy. Very good. Now, should we go back and do that again?